come to the horizontal jet pump. I explained it a bit, and you record it. Okay, so probably I won't see your chats. If you have any questions, please ask me by the mic or so. Probably I won't see your chats during. Maybe can we test it? Can you give me a thumb up? I would like to see if I can see the chat. Please give me a thumb up if. Okay, okay, Miss Gerhard, perfect. So it's possible also to give thumb ups during recording. Okay, I want to explain you a really, really interesting um, um, something, a really interesting pump concept, and it's a so-called horizontal water jet pump. It's a horizontal water jet pump, and jet pumps are really really interesting um, pump systems. So you have a big channel with water, with of course with you have a big channel. It looks like this, yeah. It looks like this. Yeah. You have a volume flow here from this side, and you have a density, and you have here a velocity. You have here 0.1, 0.2, and let's say 0.4 at the exit. And we have also here a 0.3. Okay. And this 0.3, I will come to this later, but at first I want to ask you what happens if you have here a higher velocity at this point. What could happen at 0.2? If you have here pressure 1, you have here pressure 2, you have here pressure 4, you have velocity 1, you have velocity 2, and you have velocity 4. What will happen to velocity or pressure 2 if you get a. What will happen at first? What will happen to velocity 2? You have velocity 1, and will velocity 2 be higher or lower? Will you get higher velocity? Come on, guys. Give me some. If here's a diameter 1 is bigger, diameter 2 is smaller, how will the velocity change? Of course, Miss Gerd, of course, C2 must be higher because A1 is smaller. A1 is bigger than A2, and because of this, C1 is smaller than C2. That's logical somehow. But what will happen to the pressure? What will happen to the pressure? Which pressure is higher and which pressure is lower? Yeah, P1 is higher. P2 will be lower because C2 will be higher. Okay, C1 of course will be higher, and C2 will be lower. And that's not so easy. But okay, so C2 is higher, C2 is lower, C1 is higher. So, and now because of this effect, we can do a really cool thing. We can use this as a pump. Yeah. If we now make a small vessel here and a small pipe, we insert the small pipe system, and we have a liquid here. We have fuel or oil. Then we can have a pressure here on P3, for example, and then we can pump up the oil here into our system because of the low pressure. Okay, and we can also calculate this by Bernoulli's law. The pressure P3, we have here the atmosphere. And so we have P3 should be P0 should be the same, about 1 bar. And let's say here our velocity here, it's a big vessel. Yeah. So C3 is approximately 0. And now we want to calculate C2. Okay. So we have to make Bernoulli's law, P2. Now, again, sorry, P2 plus and okay, it's not so. Okay, maybe I make a new slide. Okay. And I write it again on the next slide, so I can calculate a bit better. P2 plus C2 squared plus and then we can calculate C2 of the fuel, and it's volume flow of the fuel F. So it's 4 okay. So okay, now you can enter all the values, and then you get the result of P2 equal 0.834 Pascal, and it's about 0.83 bar. Okay, then we must calculate the point from 1 to 2 for the flow P1, and again the same. Height is the same. Yeah. And okay, for we can also fulfill the continuity equation C2 by C1 equals and okay. And then we get, if you solve this, we get C1. Now, shift it a bit to the middle. Make it a bit bigger. Okay, that's fine. We get C1 equals 0.48. Okay. Okay. That's a velocity C1. And now we want to calculate the volume flow. And I take a new slide. And this volume flow and mass flow calculations are always something you should always know. I write it in big letters. Volume flow is C1 times area 1 Yeah. No, sorry. Okay. Perfect. So that's the volume flow of our jet pump, horizontal jet pump. Okay. Is this okay? And it will be at the entry and exit approximately the same. Okay. So is this now okay for you? You can, I think you can stop the recording and